Okay, good afternoon, class. So today we're looking at Euclidean geometry. So yesterday we spoke about the proof to theorem 2, correct?
Yes, sir.
Why is it not underlined? So now we're going to look at the examples for exercise 9.2 on page 280. Sorry, 83. Okay. So we spoke about this theorem. Yesterday we proven this theorem, not so? Now in the description box below you will find the proof to theorem 2. The theorem that says the angle that an arc of a circle subtends at the center of the circle is twice the angle subtended at any point on the circle's circumference. Okay. And then we said that once we use this theorem, we will say angle at center is 2 times angle at circumference. Okay. That's the reason for this theorem. Now we're looking at example 1. Example 1 is on page. Example 1 is on page 282. Okay. Example 1 is on page 282. So here we are told that given circle center O with points A, B and C on circumference of the circle. So here we've got A, B and C on circumference of the circle with angle A is equal to 43 degrees. So this is 43 degrees. The question says calculate O1. So this is O1. Not so. So what's the size of O1? Twice 43. Why? Because the angle at center, you see this arc here, CB, is subtending the angle at circumference. Can you see that, people? So what do we say? Angle O1 is going to be, O1 is going to be 2 times 43, which is 86. And the reason there is angle at center is equal to 2 times angle at circumference. Okay. Is there any confusion here? That is 86 degrees. Now B. The B part of the question, they want you to calculate B1. But we know that B1 is the same as which angle?
C1.
C1. Why is B1 equal to C1? It will be angles opposite equal sides. And it's your radius. You must say it's because of the radius. Otherwise, you must first say that OC is equal to OB, radii, and then you say B1, angle B1 is equal to C1, angles opposite equal sides. It's the same thing. So what can I say now? I can say that 86 plus B1 plus C1, which is the same as B1. Why am I keeping it B1 and not C1? Because the question was to calculate B1. Make sense? And why don't I keep both B1 and C1? Because there's then now 2 different variables. And that's equal to 180. Why? Sum of triangles. Then it's triangle COD. Or COB, sorry. So what can I say now? You can say 2B1 twice B1 is equal to 180 minus 86, which is 94. 94. So 2B1 is equal to 94 divided by 2. So B1 is equal to? People say any confusion there? It's easy, no? Right, let's look at the next one. Example 2. In example 2, we are given circle center O with points A, B, and C on circumference. O is parallel to BC. People, if AO is parallel to BC, what do we know? Angle O is equal to angle B. Why? Alternate angles. What's the relationship between O and angle C? Angle at center, it's going to be double angle circumference. Can you see that, people? Why? Because at this arc, AB is subtending the angle at the center. That same arc is subtending the angle at the circumference. Can you see that, people? The angle at the center will always be the bigger one. No? The angle at the center will always be the larger angle of the two. Okay, just in case you don't know which one must be doubled. Okay. Then we are told that OB and OC are drawn. Angle A is 20. The angle A is 20 degrees. Okay. The question says, prove that angle B is double angle A. Okay. So what is the size of angle A? 20. If I can prove that angle B is twice 20, which is 40, then I've done the job. Not so. Let's check it again. Let's say prove that angle B is double angle A. So if angle A was noted to be 20 or given to be 20, 2 times 20 is 40. If I can prove that angle B is 40, I've done the job. You all agree with that?
Yes, sir.
Right. So of course you're not going to go straight into that. So which other angle is equal to A? C. Why is angle C equal to angle A? Alternate angles. Not so. So angle C is equal to 20 degrees. Alternate angles with AO being parallel to CB. So these 20. Now what? Can I go into B yet? No. But it's the relationship between C and O, not so? So angle O is equal to 2 times 20, which is? Why? Angle at center is equal to 2 times angle at circumference. Here's 40 now. Now what? Now we can say the alternate. Can you see that, people?
Yes, sir.
Okay, so angle B is equal to 40 degrees. Why? So alternate angles with AO being parallel to CB. But I say, hang on. Is that not that? Therefore, angle B is equal to twice angle. I know you guys are upset, no? The sum is too easy for you. No, this again, yeah? So it's too easy. Right. People, any confusion here? Okay, so that basically brings us to the end of the examples for exercise 9.2. So with that, you should be able to do 9.2 on page 283. The full lesson can be found in the description box below. Okay.